Hello everyone. Today we will be solving the daily leetcode problem. Shortest path to get all keys, and it's an hard problem. And we will try all the approaches to solve that particular problem. If I am able to solve this within 30 minutes, otherwise I will look into the discuss and then solve this particular question. Yeah, you are given an element to an grid where dot is an empty cell. Okay, slash is in wall and at the rate is the starting point. Lowercase letter represent keys and uppercase letter represents locks. You start at the starting point and move. One move consists of walking one space in one of the four cardinal directions. You cannot walk outside the grid. Okay. For some k less than 6, there is an exactly one lowercase and one uppercase letter of the first k letters. Okay, so we have at least we will be max to max 6 letters, and for every lock we have a key. And okay, return the lowest number of moves to acquire all keys. It is impossible to return -1. Okay. Hmm. So the thing is, we can use DFS or BFS for this type of traversal. BFS would be better. Hmm. And k is going up to 6 only. MN is 30, 30 into 30, 9 into 10 to the power 2. Hmm. Q. Hmm. Okay. First find out start position and and ending position. Uh, like starting position. So for I, we have to get the keys. Like it can have max to max 6 keys. Hmm. We can use bit masking. Start. Hmm. So here I am using bit masking to use it as a visited array. Like for A it will be position 0, for B position 1, uh, position 1, 2, 3 and so on up to position 6. So I am filling a first position, so it will be like if we are given only A, so the only first position is filled. If we are given A and B as well, then 1 1, and then we have if we are given uh, only A, B, C, D, E, only F, and nothing given else, then yeah, so it is somewhat like this. Yeah. Hmm. So count is our final answer. Whenever we get a count, we will return our moves. So moves is initially 0. Hmm. Directions will be we can go in all 4 directions. So above, mm, right, down, left, okay, while q, len of q. Okay, we have to append something in the q. So q dot append 3 things. Okay, start I, start j, and 0. L equals to len of q for dash in range of L. Mm, mm, AB and mm, visit. Okay, q dot pop left, going into the all 4 directions. So ni nj equals to a plus I b plus j. If ni is greater than 0, n is lesser than n, and nj is also greater than 0, n should be lesser than m. Okay, and grade of I comma j should not be wall. Yeah. Mm. If visited equals to visited equal to count, then we can return moves like mm, yeah. Mm-hmm. Okay, if grade of ni nj equals to dot, or it might be a case it is, or a grade of then we can go there, and nothing will change on the so q dot append, okay, ni comma nj comma it is visited. Elif root of ni and nj dot is lower. Then new visited. First we will be finding the value. Order of a visited or yeah. Then what we can do is we can append ni nj and new visited. Yeah, if it is uppercase, then we will be finding the of ni. Okay, if okay, visited and 1 to the power well, then we can go in this side as well. So do not append ni nj and visited. I'm thinking that there might be a loop or not. Might be. Like maybe I'm missing something. List object with no attribute as pop left. It is working. There might be a case for loop, I guess. I'm missing something for sure. It cannot be that much easy. Let's see if we are here. We are at a position and we move to this position again. We move to this position. For the next time we can move to we can move to the above position again. Okay, let's create something for like we have a wall here and a wall at the end, and similar situation there as well, and we are starting from there. We have A here and a capital A here, and so it is look like A has A has as so from there we will be going to there. Mm. For this case it should not work, I guess. Yeah, TL. Mm-hmm. Okay, so if we are starting from there, mm, mm, we are here. We should not move to the yeah. Hmm. I'm thinking what can I do. Hmm. We are here. what I'm thinking is we can create something called visited array. Not sure it will work or not, but we have to try our best. I will try for 5 to 10 minutes by myself. After that I have to see discuss. Let's see. Hmm. 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 Okay, we have filled. Okay, from this we are for position. We are going to all these 4 positions and let's do it as hmm. 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 Okay, visited. We are adding the positions and then we are moving positions. Okay. Mm. Mm. What I can. Mm-hmm. Mm. Okay, we have filled in the visited area. No. And then we don't have to use this. Mm. It might be there. I'm not sure it will work or not. Mm-hmm. Mm. No, not here. Whenever we are getting the value and we created this value, so if a new visitor is mm, then we can return moves plus 1 and we can check that if this is visited or not, the newly created. Mm-hmm. So we can check here if 9 comma new visited mm, not in visited, then we will be doing this operation. So if from this now if I see this example, from there it will go there, but if it is going to back to this position, so it came here, but the nj is going to be the previous position, but it is already visited, so it will not go there. It might work. Working. Yeah, finally 500 days. Hmm. Yeah, so the approach is somewhat simple, but the question is not. The So first we have taken the starting position and the starting row and starting column, and I push them in start I and start j, and then checking all the lowercase values. So lowercase values are the keys and the uppercase values are the locks. So for all the keys I have used bit masking, and for all the keys, like they are lowercase letters, so I have filled it with count. So count will be count equals to count or 1 to 1, and uh, right shift right shift well, and then I'm taking moves, and then these are the 4 directions, and then appending the start I, start j in the uh, keys. So in the starting we have 0 keys, so we have filled a 0, and then taking a visited array. This visited array is for checking that we have already visited that cell or not. If we have visited that cell previously, and we are visiting that cell again and again, that doesn't make any sense, and it will convert into a TLE solution, which I was having previously. So yeah, and then I'm taking the simple, it is a kind of simple BFS. Yeah, so the main thing is taking the visited array, otherwise it is a very simple question, might be tagged as a lead code second problem, contest second problem, if we don't have to take the visited. Yeah, so yeah, from this I am taking the length of the queue, and then I am popping out the element from the queue, and then moving to all the 4 directions, and getting the new cell coordinates, and then checking that this cell is in the grid or not. If it is outside the grid, we don't have to take it, and then checking it that it is a wall or not. If it is a wall, we don't have to take it, and then if it is not, then we have to check that it is uh, empty point or a starting point, and if it is an empty or starting, we have to check that it is previously visited or not. If it is not previously visited, we will appending it into the queue, and adding it into the visited array as well, and then checking that uh, new row and new column is a lowercase character. If it means that it is a key, so we are getting the new visited, which is to tell us that we have these much keys, like I have shown you the previous examples. For the simple a, it will be having a 1, and then if we are having a b and d comma a, then it will be having somewhat like 0 0 1 1. So yeah, it is kind of easy bit masking. and then I am checking that if our new visitor is equals to the count. So the count is the uh, actual actual keys in the grid. So if it is equal, so we can return the moves plus one. So plus one is because we have used ning, the next coordinate, the next cell coordinates, and we are here, so we have to do plus one here, and then checking it if it is previously visited or not. If it is not, then we will be adding it into the queue and adding it into the visited array as well. And then it is the case for the uppercase, means lock. If it is in lock, and then we have to check that we got the key for that lock or not. If we get the key, then we are checking that it is it the cell is previously visited or not. If it is previously visited, then we don't have to consider it into the queue and visited. If it is not, then we are appending it into the queue and adding it into the visited array as well. And in the end, if we got our answer, it will be break in the continuation, and otherwise it will return the minus one. Yeah, so that's all from this video. Let me know in the comment section if you have any doubt. It is kind of an hard problem. Yeah, it's taken a lot of time. Yeah, thank you.